Hi everyone, welcome to my Capstone presentation on Canadian unemployment trends. This project looks at how employment and unemployment have changed in Canada since 1976. I used Python to clean, analyze, and visualize the data. The dataset was downloaded from Kaggle and comes from Statistics Canada. It includes monthly labor force statistics from 1976 to 2023. I use Python libraries like pandas for data wrangling and matplotlib and seabound for visualizing trends. And this is how the project looked like. This is the project overview, and it includes data acquisition from Kaggle and initial data processing, feature engineering, exploratory visualization, and summary insight at the end with the conclusion. Let's move on to the next slide. These are the project objectives. Analyze long-term unemployment and labor trends across Canadian provinces. Use historical data from 1976 to 2023 for time series insights and identify disparities by region, age, and gender. And I imported the datasets into Python using pandas library. The data includes provinces, age groups, and labor metrics like employment, unemployment, and population. Once loaded, I reviewed the data to understand its structure and began preparing for its analysis. Moving on. On the initial data processing, I cleaned the data to make it easier to work with. I converted the date format so I could extract year and month from it. I also removed any missing or invalid values and rounded the large number like employment counts to whole numbers for better readability and visualizations. Also, I removed any rows with missing data and rounded the numerical columns for clarity. To make the data more meaningful, I added some new features. One example is calculating unemployment per 1,000 people. This allowed fair comparison between provinces even if the population were very different. I also created a ratio of full-time to part-time jobs to track how employment types have changed. Also, I have created new columns in Python based on existing ones to show normalized unemployment and job type ratios. This helped reveal more useful patterns during visualization. I used Python libraries like Seaborn and Matplotlib to create charts and graphs. This included line charts, bar graphs, and heat maps. They help me to understand the trends across age group provinces over the time. This charts gives the unemployment per 1,000 people by age group. I grouped the data by age and year, and then I created a line chart to compare how each group was affected over the time. This line chart shows how employment per 1,000 people changed over the time for each age group. Youth unemployment was the highest and most unstable. People aged 25 to 54 had the lowest and most stable rates. On this unemployment versus population chart, I summed the total number of unemployed people and population for each year, and I plotted both lines together to visualize their relationship. And I compared the number of employed people to the total population. It helps show how unemployment changed over the time, especially when the population is also increased. This full-time versus part-time ratio chart shows how the balance between full-time and part-time jobs changed. The line is slowly going down, which means part-time jobs have become more common in Canada over the time. This heat map shows how unemployment levels varied by province and year. Provinces like Newfoundland and Labrador had consistently higher unemployment, while Alberta and Saskatchewan were more stable. For this chart, I organized the data into table where years go across the top and the province down the side. I used color shading to show which areas had higher or lower unemployment. And moving on to the next slide, these charts compare the average employment rate with the average population for each province. It shows that provinces with large populations like Ontario don't always have the best employment rates. Smaller provinces like Alberta may perform better in terms of job rate. Here are my final takeaways. Youth unemployment is the highest and most unstable. Ontario and Alberta shows different trends. Alberta has better employment despite being smaller. Full-time work is declining while part-time is growing. COVID-19 exposed how fragile part-time jobs can be. Some provinces like Newfoundland face long-term unemployment issues. All of this points to need for smart, data-driven policies to better support the labor force. These are the tools I used for this project. Thank you for listening to my presentation. This project helped me to understand how to use Python to analyze real-world problems and how to turn raw data into clear insight using code and visuals. Thanks again.